Welcome back to my channel. I hope everyone is doing great. My name is Ravitija. Let's solve Leetcode problem 3713 longest balanced substring 1. You are given a string S consisting of lowercase English letters. Okay? A substring of S is balanced if all distinct characters in the substring appears the same number of times. Return the longest length of the longest balanced substring of S. Okay, if you look at this example, there are various substrings which can be formed. Okay, let me just write it down over here. Okay, if you see AB, this entire string is a substring. Okay, I can say A itself is a substring. Again, AB is a substring. Correct? ABB is a substring. Okay, ABA is a substring. Sorry, ABA is a substring, and ABC is a substring. Now I can again start from B and repeat the same process. Now B is also a substring, BB is also a substring, and so on and so forth. That means I can start at a particular index and go and get the substrings of increasing lengths, and all of them will be my substrings. Okay, I can start at B and get the lengths substrings of increasing lengths like 1 2 3 all the way up to the end of the substring, and then those are also a valid substrings. Okay, now if you look at the those are the substrings which are generated. Now we have to also check whether the each substring is balanced or not. Okay, it is no said as balanced if the distinct characters has same frequency. Here we have only one character and its frequency is 1, so it is balanced. Okay, if you see A and B both have a frequency of 1 comma 1, so this is also a balanced. Okay, here A is 1 but B is 2, so this is not a balance. Okay, this is balanced because A is 2 and B is 2, so this is also balanced. Okay, and you can do this process for all the substrings. If you look at the constraints are the length of a string is up to 1,000. Okay, so even if you even if you generate all the substrings and check whether each substring is balanced or not, will be satisfied for this solution. Okay, so generating all the substrings would take order of n square, because for each index we are going all the way up to the n and trying to generate the substrings of various lengths, right? So generating substrings would take order of n square, and checking whether a given substring is balanced or not, because that would take constant time, because we have only distinct lowercase letters. Okay, which is basically 26 characters we will be having in lowercase English. Okay, so we can simply have a frequency of size 26, and then check whether the given frequency array, okay, the characters which are appearing have the same frequency or not. Okay, so let me show you the implementation, brute force implementation, which I have done. Okay, so by default every substring of length 1 is balanced, right? So my default answer is always 1. Okay, even though let's say we have a string of a to z with all appearing as ones one time, then my longest balanced substring length would be of size 1. Okay, now that I am starting from index I, which is at 0, going all the way up to the length, and I'm also having a one more pointer j which will start at I and go all the way up to the end. Okay, my I will go from 0 to n, and my j will also go from j will start at I and go all the way up to the length of the string. Okay, as I mentioned, while generating the substrings we should check whether each substring is balanced or not. Okay, in order to check whether each substring is balanced or not, I need a frequency array, right? So I'm just updating the frequency of the corresponding character in my frequency array, and then after adding a particular character into my frequency, I will check whether the so far generated substring is balanced or not. Okay, if it is balanced, then I will try to maximize my answer so far, right? So the current string will have a length of I minus j minus I plus 1, and so far with so far answer we are trying to maximize it. Okay, and then my answer will contain the maximum length, okay, of a substring which is balanced. Okay, now let's look at is balanced function. Okay, it is taking a frequency array. Now the moment we have encountered a character whose frequency is not equal to 0, that means all other characters which are also appearing should also have the same frequency. So initially I kept count as -1, indicating that i have I haven't encountered any character which is appearing. Now I will go from 0 to 26. The moment I encountered a character whose frequency is non-zero, then if this is the first time, okay, if count is -1, that means this is the first time. So I will update my count with the frequency of the current character, and next time I will always check whether the rest of the characters whose frequency is non-zero should be equal to the count. Okay, if it is not equal to the count, then I will be simply returning false, or else I will return true, because all the characters which are appearing has a frequency, as the same frequency. Okay, so as I mentioned, the overall time complexity is big of n square times 26, where 26 is constant, so we can say big of n square. Now in terms of space complexity, we are using an extra space of big of 26, which is also constant, we can say constant space. Yeah, that's all about this problem. If you like the explanation, hit the like button, hit the subscribe button. I will post the solution in the description. You can basically check out over there as well. Yeah, that's all. Thank you, and don't miss to subscribe to my channel and hit the like button.